Right-click to create a node. Choose Oscillator. Then connect the ports to hear a sound. Frequency and detune control pitch in different ways. There are also waveform selectors and a volume slider. Let me show you more interesting ways to control the oscillator. The first node on the list is the gain node. By itself it can't control the oscillator, but we'll see it again later. Next we have the oscillator. It can control an oscillator. Oscillators output between 1 and -1, so it's hard to hear a difference. Increase the oscillator's output by inserting a gain in the connection. Then increase the value of the gain. It goes without saying that we can elaborate. Next is the sample node. Go to Utils, Samples. Here we can create our own samples using a formula. This simple formula only produces numbers 1 and -1. We can zoom by using the mouse wheel. The sample sequencer. It's a sequencer that plays samples. The gate sequencer creates a sequence from its inputs. The number value. I'll have to admit, it has kind of a stupid sounding name. All it does is act as a knob. But the cool thing about it is, it can control multiple things at once. Used in conjunction with other nodes, it can be very powerful. Filters can't control the pitch of oscillators directly, but they can shape the character of those controlling it. Delays are not particularly useful for controlling the pitch of oscillators. Same with panner. Sample piano rolls are like sample sequencers, but more flexible in a way. The mono piano roll was made specifically to control pitch. Envelope shapes the individual notes. Modules. Compression. Honestly, I never use it. The processor. There is a lot you can do with it. But you need to know JavaScript. The second output of the default processor is for controlling the pitch of an oscillator. Here's what it sounds like. We add a detuned oscillator for effect. Try changing some values. The other output creates its own sound. Check it out. Here's a cool way to create random pitch. Notice that every time I set the frequency of the control oscillator to 0, the pitch changes. That's because setting it to 0 freezes its state, somewhere along the curve. So the idea behind this random pitch technique is to, very briefly, increase then decrease the frequency of that oscillator. We can use an oscillator and a gate sequencer to achieve this. I'll use the oscillator's built-in gain to increase its amplitude. Then we connect it to the gate sequencer. And finally we set the envelope to a minuscule blip, using the 4 knobs on the top right corner. We can also use an oscillator fed into a processor, as a pitch quantizer. We can combine this with the random pitch technique from before, to create quantized random pitches. Well, there you have it. Go on and have fun with nunisynth. Get out of here.